Okay, so let us start. What we have discussed in the last class. We have started quantum mechanics. Okay. Hello. I am audible.
Yes.
Yes, sir.
Yes, sir.
We have started quantum mechanics in the last class. So have you seen some books?
No, sir.
किताब उताब देखा है आपने? वन मिनट यार क्या कर रहे हो? Okay, we will start. Let's see. So, we have discussed drawbacks of the classical mechanics and introduction about the quantum mechanics, why we need quantum mechanics. Okay. Now, there are two ways in which we can classify the quantum mechanics. So now we will start from this one. Just like suppose that I will show. We can say this one. Now this is visible to all of you.
Yes, sir.
Yes, sir. You are visible.
Okay. So we will start. Just see. Last in the last class, I told you that we are going. We have classified the classic. It means we are dividing the quantum mechanics in two parts. First part depends upon the Planck's hypothesis. Okay. And second part depends on the de Broglie hypothesis. Okay, so in the first part that was called the old quantum mechanics, and by using the old quantum mechanics, we have explained the phenomena of black body radiation, photoelectric effect, and Compton effect. Okay, and by the modern quantum mechanics will start from the your de Broglie hypothesis. So here I am left the old quantum mechanics. I will discuss that portion in the later. Okay. Photoelectric black body radiation, photoelectric effect, and Compton effect. I will discuss in the later when my PPT will be prepared. Here we are starting from the de Broglie hypothesis, means we are going to start the modern quantum mechanics. So modern quantum mechanics will start from the de Broglie hypothesis, and de Broglie hypothesis states that if a moving if a moving material particle, if a material particle is moving with a velocity near equal to the velocity of light, okay, so a wave will be associated. Just like material particles means electron, we already know photon is the quanta of the electromagnetic wave, and it has the velocity equal to c. But the material particles which are moving near equal to the velocity of light, a wave will be associated with material particles. Just like photon, since photon is a massless particle, it has been already discussed in the relativity that photon is a massless particle, but it has energy and momentum. This is clear. So photon will behave like particle as well as like wave. Similarly, the material particles which are moving near to the velocity of light, they also behave like particle as well as wave. So de Broglie states that material particles moving near to the velocity of light show dual nature. Dual nature means it will show the particle property and as well as it will show the wave property both. Just like photon show the material wave property as well as the what we say particle property. So de Broglie states that the material particles which are moving with the velocity of light are near equal to the velocity of light. They show dual behavior, and this dual behavior statement is called the de Broglie hypothesis. And according to the de Broglie, you just see this word file whatever open. I am just zooming this one. Now this is clearly visible to all of you. Okay. So whatever the wave associated with the moving material particles, that is called the matter wave or the de Broglie waves. Okay. And according to the de Broglie relation, the wavelength of the associated wave lambda is given by the formula h upon p. P is the momentum, h is the Planck's constant. So this will be h upon m into v. V is the velocity of the particle and m is the mass of the particle. Okay. So this is now this will be different for different one. Just like suppose that if we are considering there is a role of only mv, mass into velocity. Suppose that if we are considering electron, so electron what will the energy, kinetic energy of the electron? याद है? I am audible?
Half mv square, sir. Dynamics.
Half mv square. So if you multiply it,
But in terms of momentum, sir, p square by 2m is.
So this will be equal to twice, in the case of electron, this will be equal to twice MeV. How you can calculate? Similarly we can consider for the case of neutron. Okay. So here we can calculate the mute their mic. Here we can calculate the kinetic, we know the kinetic energy formula for the electron, kinetic energy formula for the neutron and other particles also. So by putting the value of K for different particles, we can calculate the wavelength of the associated wave corresponding to that particle. So here, so this is the de Broglie hypothesis and this is the de Broglie relation. Lambda is equal to h upon p. When you will plot the graph between lambda and 1 upon p, this will be like a parabola. Okay. This will be look like the parabola. So this is the de Broglie waves. So de Broglie waves फिर से मैं explain कर रहा हूँ, ध्यान से सुनिएगा. De Broglie statement is that if any material particles moving with the velocity of light are near equal to the velocity of light, it will behave like particle as well as like wave. And this is called the dual nature of the particle. So for particle property, it is necessary that particle will show photoelectric effect, Compton effect, and one more experiment. While for the wave property, it is necessary that that material particle will show interference phenomena, diffraction phenomena, and polarization phenomena. So the photoelectric effect and Compton effect represent the particle property, particle nature, while interference and diffraction represent the wave nature of that material particle. So this is the relation. This lambda is equal to h upon p is called de Broglie relation. H is the Planck's constant, p is the momentum of the particle, and when we'll put the value p is equal to m into v, here you just see one more thing. This is the in relativity, you know. आपने मास वेरिएशन पढ़ा है ना रिलेटिविटी में?
Yes, sir.
Yes.
सो वहां भी जब हम कोई भी पार्टिकल अगर नियर इक्वल टू द वेलोसिटी ऑफ लाइट मूव करती थी तो वहां पे हम क्या रिलेटिविस्टिक मास कंसीडर करते थे. सो हियर m इज आल्सो द रिलेटिविस्टिक मास. ओके, but here you will not calculate, it will be given directly to you. So whatever the mass we are considering, that is the relativistic mass of that material particle. So the smallest wavelength that can be measured is related to the gamma rays. Now just see what is the meaning of this one. अब देखो, just like suppose that हमने कहा कि I will explain कि if a material particle is moving near to the velocity of light, so what will be happen? A wave will be associated. So how we हमने de Broglie ने तो give the theoretical predictions, but how we can verify? So to verify this matter wave, an experiment was performed by the Davison and Germer. This is called the Davison-Germer experiment, and this experiment is giving the confirmation of the matter wave. It means matter wave exists. This is the first experimental evidence that is given by the Davison-Germer. So here I have already mentioned the Broglie hypothesis was confirmed by the Davison-Germer experiment, and it is used to study scattering of the electron from a solid or to verify the wave nature of electron. What is the actual experiment that Davison and Germer takes a nickel target, okay? And on nickel target they bombard the electron, high speed electron, and they noted the scattering at different angle. जैसे आपने एक्सरे देखा है ना, so what is will be happen, just like suppose that if this is the nickel target and electron is being bombarded on this nickel target, so from different planes, since nickel is a solid material, so there will be a different planes. So from different planes it will be scattered in the different direction. So Davison and Germer note down that different scattering angle. So here I have already mentioned it is used to study the scattering of electron from a solid. That solid means that is the nickel target, to verify the wave nature. A beam of electron emitted by the electron gun is made fall on nickel crystal cut along cubical axis. Nickel crystal behave like a three-dimensional diffraction grating, and it diffracts the electron beam obtained from the electron gun. आपको डिफ्रैक्शन रेटिंग में पढ़ाया था, तो डिफ्रैक्शन रेटिंग में बताया था कि जब कोई रे ऑफ लाइट इंसिडेंट होती है तो क्या होती है, they will diffract in different direction. याद है आपको कि भूल गए?
Yes, sir.
तो सेम कंडीशंस विल बी अप्लाइड हियर. देखो वहां क्या है कि जो हमने लाइट वेव डिफ्रैक्शन आपको पढ़ाया है, in that diffraction we required a diffraction rating, because whatever the wavelength we are using, that should be of the order of angstrom order. Angstrom means that is from 4000 to 8000 or something like. Suppose that if ultraviolet to from ultraviolet and above. But when we are going to the downwards, just like for the X-ray or gamma rays or neutron rays, so what will be happen in that case? This optical grating will not be used. because the separation between the gratings will be greater than the whatever the wavelength we are using. But to diffraction condition is that ki our obstacles, width of the obstacle should be of the order of wavelength we are using. So this is the reason why we cannot use visual light to find the structure of crystal, because the wavelength of visual light is greater than the crystal structure. भाई आपका एटॉमिक डायमेंशन कितना होता है? मैक्सिमम 1 to 10, but we are in visual light that is 4,000 to 8,000 angstrom. So we cannot use visual light to study the structure of crystal, but we will use gamma ray or X-ray, because these waves have wavelength comparable to the atomic dimension. So when electron will be bombarded on the nickel crystal from different planes of the crystal, just like one plane, second plane, third plane, fourth plane. This is the structure of the nickel crystal. So from each plane, electron will be scattered in different direction. It means it is behaving like a grating. So Davison and Germer noted down that scattering angle at a different voltage. भाई आप देखिए, जैसे मान लीजिए पहले आपने 1 वोल्ट दिया, okay, so you will get some electrons. You noted down that reading. Again you give 5 volts. Again you noted what is the scattering direction of the electron. Again you give the suppose that 10 volts. Again you noted down. So similar experiments will be performed by the Davison and Germer. So you just see the energy of the incident beam of electrons can also be varied by changing the applied voltage. हमने voltage change किया, इलेक्ट्रॉन की इंसिडेंट बीम की एनर्जी इंक्रीज हुई, and due to that scattering will take place. So Davison and Germer noted down different at different voltage, different scattering angle, and he find that this is maximum at 54 volt potential difference. Okay, he noted down here according to the classical physics, the intensity of the scattered beam of electrons at all scattering angle will be same. Okay, but Davison and Germer found that intensity of the scattered beam of the electrons was not same but different at different angle of scattering, and this intensity of the scattered beam is maximum at different angle 50 degree. This is the result which is possible at 54 volt potential difference. So here you just see figure. This is the intensity of the incident beam. This is the voltage at which they find this intensity, and they see that whatever the kink you are seeing, in the whole experiment, you will observe this kink. If you will go through the book, here I am not showing that part, all these figures. So in books it is given at 0 degree, what is the shape of this one, at 10 degree, at 20 degree, at just like by increasing the potential. So he found that this kink is maximum. Kink is maximum means intensity of the incident beam is maximum at 54 volt, and this is at 58. This is at the scattering angle of 50 degree. So this is the maximum intensity whatever they observed. So by using this maximum intensity, they calculated their results. So we have two formulas. First, we will apply, because we are going to correlate wave properties and particle properties. So here, suppose that given that the de Broglie wave exists for the electron, then this should be the diffracted X-ray. Okay. So by using Bragg's formula you know 2d sin theta is equal to n lambda, d is the spacing, theta is the diffracting angle, n is the order of spectrum. He calculated whatever he calculated, I will show. Just like what is the diffraction is possible, this is represented in this figure. So this is the small d, the distance between the two planes of the nickel, and by geometry he found that diffraction angle theta is equal to 180 minus pi by 2. So when we will apply the de Broglie wave equation, lambda is equal to h upon v, that is equal to h upon p, h upon root twice mk, k is equal to E into v in the case of electron, and we know this applied potential is 54 volt. So when we will put the value of E and B in equation to find that the lambda is equal to 0.167 nanometer. Okay. Now same results will be used for to calculate lambda by the Bragg's equation. So now in the case of this one, D is given 0.092. This is the standard of the nickel. V is equal to 54. The angle of diffraction is 50 degree. So here they have put this value, and for first order spectrum they calculated that lambda is equal to 0.167 nanometer. So they calculated wavelength from two ways. One from the de Broglie hypothesis and second from the Bragg's law. So de Broglie hypothesis represent the wave nature and Bragg's law represent the particle nature. So from this one he found that the wavelength of that X-ray is the same. So he concluded that the experimental results are in close agreement with theoretical value got from the de Broglie hypothesis. Hence, equation 3 and 4 verify the de Broglie wave equation. So, this Davison-Germer experiment gives the confirmation of for the existence of the matter waves. ये आपको समझ में आया?
Yes, sir.
भाई देखो कुछ है नहीं एक्सपेरिमेंट में, सीधा सीधा है. पहले उन्होंने निकल क्रिस्टल लिया, ठीक है, निकल क्रिस्टल पे दे बम्बार्डेड द इलेक्ट्रॉन्स. सो अगर मान लीजिए जैसे आप टू इंक्रीज द इंटेंसिटी व्हाट यू विल डू, यू विल इंक्रीज द पोटेंशियल डिफरेंस. सो दे वेरी द पोटेंशियल डिफरेंस. It means they varying the energy of the intensity of the incident beam. And since crystal structure states that this constitutes of the parallel planes like this one. So from different angles, from different planes, the electron beam will be scattered. So they noted down the intensity with respect to the applied voltage, and they observed that at which angle they are getting the maximum kink, that is called the kink. So they found that at 54 volt, the maximum kink is the 50 degree. Beyond 54 volt, when you see the book, I am saying here, you will go through the book and see after 54 volt, that kink will start disappearing. Initially, when from 0 volt, 10 volt, this is being increasing. At 54 volt, this is maximum. After 54 volt, that kinks start disappearing. So he concluded that the maximum intensity will be observed at 54 volt and the angle of diffraction is the 50 degree. So now they use both equations. First they calculated theoretically. Theoretically means from the de Broglie wave equation, they calculated the wavelength. For experimental verification, they applied the Bragg's law, 2d sin theta is equal to n lambda, and in both cases they found that the wavelength are same. So it means theoretical value and experimental value are in close agreement, so it confirms that the material wave or de Broglie wave exists. Okay. Now here, this is clear. Then I will go forward.
Yes, sir.
Yes, sir.
Okay.
Sir,
Now we will
sir.
go quantum
Sir, sir.
mechanics पढ़ते समय एक चीज याद रखना, quantum mechanics is very easy. और
Sir, one doubt.
अगर आपको एक बार समझ में आ गया तो इससे इजी कोई यूनिट नहीं है आपकी, और अगर समझ में नहीं आया तो ये आपको कभी समझ में नहीं आएगा. अब देखिए, जैसे हम आई हैव स्टेटेड that each material part moving material particle corresponds to a wave. So you know, you are already familiar with the sound wave. Sound wave का नाम सुना है ना?
Yes, sir. Yes, sir.
So in the case of sound wave, you write the, when you are picturing the waveform, this is y-axis, this is x-axis, and you are you are plotting the wave like this one, sinusoidal wave. Okay, so on y-axis you are representing the displacement. Displacement y, and on x-axis you are representing the v into t or sin omega t, whatever you are representing. So on y-axis you are representing the displacement. Similarly, suppose that if you are considering the mechanical waves, or we are considering the electromagnetic waves, so on y-axis we are representing the variation, what is being varied with respect to someone. So in the case of material particle, what should be vary? That is the question. भाई हम वेव ऐसे तो कर नहीं सकते. We want to say something will vary. So what should we represent on the y-axis? So in the case of material waves, there is a function called there is a term called wave function, and we will represent the wave function. So what is the wave function? If there is a wave associated with the material particle, then there must be a function to represent it. इसको represent, कुछ तो represent करेंगे, and this function is called the wave function. Now we just see here, I have seen this symbol. This is called the psi, and this psi represents the wave function, and this is equal to a plus ib. This is a complex variable. Complex variable का नाम सुना है ना? Complex quantity का.
Yes, sir.
Complex में क्या होता है? There will be a real part and there will be a imaginary part. Okay. So this wave function is represented. This is very interesting. Try to understand. The wave function, this will represent the variation of the material particle, and this is represented by a complex quantity, and this is called psi, and psi is equal to a plus ib, where a is the real part, this I into b is the imaginary part. I की value जो होती है that is equal to square root of -1. Okay. So suppose that if we are considering the complex conjugate of psi, so what will be the complex conjugate of psi?
A minus IB.
पेन पेंसिल रखा है आपने? What will be the complex conjugate?
A minus IB.
A minus
A
IB.
minus ib. Okay. So here we need to normalize this wave function. We need the complex conjugate. So you remember what is the complex conjugate? Psi equals, this will be psi star, and this will be equal to A minus IB. Now you just see this psi has no physical significance in the case of material particle. Why? I will explain. Just only mod psi square. Okay? Mod psi square has the significance and it is called the probability. Okay? Now just suppose that y psi has no physical significance. So when we will multiply psi star, so in some wave function, psi may be anything. Psi will be to the power x, psi will be a sin x, psi will be a cos x, psi may be anything, many wave function. But we have certain rules to accept which wave function is acceptable in the case of material particle, and I will provide that condition. So psi itself has no physical significance, but the square of its absolute magnitude, that is mod psi square, you just see this mod psi square has physical significance and it represents the probability of finding the particle. You remember, mod psi square represents the probability of finding the particle at a particular point and a particular time, because psi is the function of space coordinate and time coordinate. Psi is equal to आपका होता है x t. Psi is the function of space coordinate and time coordinate. So psi itself has no physical, y itself has no physical significance, because suppose that we are considering some functions, when we will take the complex conjugate and when we will find we'll take the square of that the square of its absolute value, so sometimes it may be negative. Okay, and you know that probability will never be negative, it will lie only between 0 and 1. Okay, so in some cases psi mod psi square will be negative. This will be possible only when that wave function will not be acceptable. So this is the reason why psi itself has no physical significance. Only mod psi square has the physical significance, and that mod psi square represents the probability of finding the particle, and this mod psi square is represented by psi star. Means we will multiply the complex quantity with their corresponding complex conjugate. So this is the wave function. Okay, thank you. Next class I will explain this one more. Okay.
Yes, sir.
Okay, send me the attendance. In the next class I will explain more things.
Yes, sir.
Okay, thank you.
So
Send
can
me
you please
the
upload the
Thank you,
notes?
sir.
notes भेज देंगे, पहले पढ़ तो लो.
सर बुक्स क्वांटम फिजिक्स के लिए कौन सा सही रहेगा?
Go through the Weiser book.
Okay, sir. Sir, lot of topics are missing from that book.
Where?
Sir, Arthur Weiser book, sir.
Why?
Sir, some topics of quantum physics are missing from that book.
No. Nothing is missing. You are not able to find in the Weiser. Photoelectric
Okay.
effect is given, black body radiation is given, Compton effect is given, quantum mechanics is given. There are 3 chapters further in the case of quantum mechanics. But you don't go in the 3 chapters, you will go. Actually, what is in the case of Weiser, they have given in the sequence order in different chapters.
Okay.
Okay.
Okay, sir.
आपको मिलेगा सब कुछ,
Once again.
लेकिन आपको अलग अलग चैप्टर में, जैसे फोटो इलेक्ट्रिक इफेक्ट, कंपाउंड, ये सब एक जगह मिल जाए. दे विल lie in the particle property, particle nature. But Heisenberg uncertainty principle, this Schrodinger equation, and all these things are in the next chapter onwards. So you will go in every chapter, you see how in Biger it is given. And try to solve the numericals from the Biger.
Okay, sir.
Okay, everything is given in Biger, nothing is missing. You try to find. Okay, thank you. Send me the attendance.
Thank you, sir.
Yes, sir. Sir.
Thank you.
Thank you, sir.